Okay, let's get started. Thank you so much for joining the call today. I'm going to take an opportunity just to share some house rules. We will have quite a few people on the line. So if you do have any questions, could I please ask you to either pop them in the chat panel or raise your hand in the meeting, and we'll answer all questions at the end of the call. For the purpose of the call, could we ask that everybody stays on mute so that the lines don't get too busy? And what we'll do is we will make sure that you have a copy of this webinar sent to you via the recorded link post the event. So for now, I'll pass you over to Alec Danmere, who's just going to walk you through a little bit of information about Interworks, who we are and what we do, and then we'll launch into Tableau and Snowflake, a match made in data heaven with Chris Hastie.
Hi everyone, thanks for the intro, Vicky. So I'm an account manager here at Interworks. Quick and brief overview to Interworks for those of you who may not have heard of us or may not have heard much about us previously. Interworks, we're a global leading data consultancy. So we deliver a full stack of bespoke data solutions, and this include but not limited to consulting, training, and software licensing. So we partner with only the best vendors, with the best platforms and the best software. A mantra that I always hear from our CEO is we aren't interested in being the biggest, we're interested in being the best. So to say we are the best at what we do. And we're the only data consultancy in the world that provide a 360 full stack of solutions to clients' data needs. We partner with the best solutions being which of Tableau, Alteryx, Snowflake, and Fivetran for ELT needs. So we also have Chris on the call here, who I'm going to hand over to in a minute. As you can see here, we have the agenda. It's a bit of a Tableau introduction to Snowflake. And then we're going to show a bit of a hands-on Snowflake demo, social workload isolation, data sharing, and then we can conclude with any questions. So Chris, if I can hand it over to you.
Thanks, Alec. So, Tableau has been a company since 2003 and has maintained the same mission statement: to help people see and understand data. To achieve this, Tableau deliver an enterprise analytics platform that will empower and elevate your people, increasing the value that they provide to your organization. The Tableau Business Intelligence and Visual Analytics platform consists of 4 main products. The first product is Tableau Prep, which helps you clean, shape, and prepare your data for analysis. Following this is Tableau Desktop, the main authoring tool. With Tableau Desktop, you can connect to data wherever it may be and use powerful drag and drop analytics to create visualizations and dashboards. The last 2 products combine to form the sharing part of the platform: Tableau Server and Tableau Online. Tableau Server allows you to share data, visualizations, and dashboards either on-premise or on the public cloud. Tableau Online has similar functionality to Tableau Server, but it is hosted on the cloud and maintained by Tableau. These tools combine to provide a full data journey from initial data access and connectivity through to visual analytics and collaboration. The second platform we are discussing and demonstrating today is Snowflake. On a really high level, Snowflake is 3 things: a full SQL data warehouse, built for the cloud, and delivered as a service. This means that Snowflake is a fully ANSI SQL compliant data warehouse. SQL has been chosen as this is commonly understood throughout the market, and it's easy for new users to pick up. In addition, Snowflake is built from the ground up to suit today's cloud-oriented world without any legacy issues from upgrading a previous platform. Finally, Snowflake is delivered as a service. This means you don't have to worry about patches, upgrades, or maintenance. Going further, you don't need to do any indexing, backups, or similar janitorial tasks, which are usually required when managing a data warehouse. The key differentiator which separates Snowflake from traditional data warehouses is the architecture. Snowflake's founders were from Oracle originally and witnessed the built-in constraints of older technologies, These legacy systems typically fell into one of two categories. First, we have the shared disk systems. These systems are limited by the box that you're running on and are vulnerable to resource contention between compute nodes accessing the same data. Second, we have shared nothing type architectures. Here, storage and compute are really tightly coupled together, and there are many nodes to run on. The intention is for this approach to be scalable, and this intention is met. However, it faces several issues, including not being elastic. Rather than pushing a button to scale the system, it takes a lot of time and effort. Snowflake have created their own architecture, which they have called the MultiCluster Shared Data Architecture. Storage and compute are completely decoupled, allowing the flexibility to grow each piece as needed without growing them both in tandem. In addition, you can spin up individual clusters on demand for specific jobs, as and when you need them, automatically turning them off again when activity ends. These compute clusters are called warehouses. A key feature is that you're only charged for what you use. Whilst the warehouse is turned off, you're not being charged for it. When a warehouse is scaled down, you're being charged less for it. This functionality streamlines into 3 layers. The storage layer maintains a single copy of each data source and is maintained separately to compute. The compute layer uses warehouses to load, manage, analyze, and query data with full scalability and elasticity. The service layer automatically performs the standard maintenance activities such as backup management, security control, and indexing. This leaves you and your team to focus on what matters, while Snowflake keeps your system secure, resilient, and efficient. I've mentioned scalability and elasticity of warehouses several times now. Let's consider an example compared to a traditional data warehouse. Here we have a line representing typical activity on a data warehouse. Perhaps this is a single workday where a few people used the system before lunch, the system was then very quiet over lunch, and then it hit peak usage in the afternoon. A traditional system will be designed to cope with the peak usage. As a result, a lot of the power behind the system will go unused when the usage decreases. As the system is not elastic, any costs involved in running the system remain at peak usage despite reduced activity. Now consider a warehouse in Snowflake. As you can see, as usage decreases or increases, Snowflake reacts to provide the appropriate functionality. If usage exceeds a previously expected maximum, a traditional data warehouse will face resource issues, while Snowflake can simply spin up another warehouse automatically. As I mentioned earlier, you only pay for the compute you use, so each time a warehouse scales down, the cost reduces. Warehouses which are not in use will not cost anything at all. So I'd now like to dive into Snowflake and give you a little bit of a hands-on demo on what we can do. So this is the Snowflake user interface. As you can see along the top of the screen, we have our databases, shares, warehouses, which are our compute clusters, worksheets where we write our code, and our history. Right now, we're in the worksheets area where we write code. So on the left-hand side, we can see all of our databases. And at the bottom, we can see a results pane telling us the results of the most recent query. The first thing I'm going to do is I'm going to drop the database that we're going to be using to demo today, along with both the warehouses. The reason I'm doing this is just so that you can know when watching this demo, everything we're doing is on a completely fresh system. It's a fresh start. There's no caching, there's no warming up of the data, anything like that. It's all completely fresh. Everything you see, all the speed is as is from the first run. Now, as I mentioned earlier, Snowflake is built using SQL as the main language. Don't worry if you don't understand SQL right now. We're not really going into what the code is. I'm just going to be running a few lines and explaining what they do. So the first thing I'm going to do is I'm just going to create a database schema and a few tables for us to use in this demo. Once we've executed that, we can look at warehouses. So as I mentioned before, warehouses are the scalable and elastic compute layers. We can have multiple warehouses. In fact, we can have as many as we like, and each one can be configured in its own way. We can configure this with code or in the UI. And I'm going to dip over to the UI first. So if I navigate to warehouses along the top, I can go to create a new warehouse. I give it a name, and then I can choose a size. As you can see here, every size is twice as large as the one before it. And this is represented with the credit system. So a small warehouse is twice as powerful as an extra small warehouse. A large warehouse is 4 times as powerful as a small warehouse. So it exponentially increases in power as you go up the list in sizes. What does this mean? This means that for today, when we do our demonstration using a small warehouse and a large warehouse, we can expect our large warehouse queries to run with roughly 4 times the performance because the engine behind it is 4 times as powerful. We also have this auto suspend option, which I mentioned previously as well. This is the option which enables me to say, okay, the warehouse isn't being used, turn it off. So if nobody uses the warehouse for 10 minutes right now, it'll turn itself off, it will stop charging, it'll be gone. And then this second option underneath, this ticked auto resume, is what allows me to automatically turn that warehouse back on. So if nobody's used it for 10 minutes, it will turn off. Then if somebody tries to use it, it will seamlessly notice and turn itself back on without the user even seeing that it's gone down. It's just nice, seamless, instant turning off and on of resources. Now, most things in the UI can also be converted into SQL if you'd like to go in a little bit of a step further. So each UI option has a show SQL in the bottom left corner. And if we click on that, you can see it just gives me the SQL that could be used to generate that particular warehouse. Let's go back to our worksheet. So I'm going to create 2 warehouses, a large one and a small one. They're both set to turn themselves off automatically after 5 minutes. So the only difference between these is obviously the large one is 4 times as powerful as the small. Now that we've created our warehouses, we are going to load our data. The data which we will be using today is a data set covering all flights which took place in America over a 25-year period. As you can expect, this is a pretty large data set. We have 148 million flights in our data set, equating to 148 million records of data. Each record has 50 columns, and the full data set is about 6.5 gigabytes when compressed. This is stored in 64 files in an Amazon S3 bucket. Amazon S3 is Amazon's simple storage service. Whilst today we're ingesting data stored in Amazon S3, it's worth noting that Snowflake can ingest data from many other locations, from flat files saved on a local machine, through to files stored in Microsoft's own equivalent cloud storage service. It's also worth noting that we're in the UK using an EU Snowflake environment, whilst the data we are ingesting is in the US. So we are not only demonstrating excellent loading speeds for large volumes of data, but this is also being performed across continents. We can expect this load to take just under 2 minutes. Once the data is loaded, the results window at the bottom of the screen will list the 64 files which we have loaded, along with the record count in each and a few other helpful pieces of information. So we'll just wait for this to finish, and then we can show you that results window. If we were running this within a US server or a US environment, we would expect this to be even quicker, simply because we're not facing that cross-continent latency. But we can expect this to finish, I would say, about now. So here we have 64 rows of data, or 64 files. Each one has been loaded. Each one has about 230,000 records. And this adds up to the 148 million records of data, that's 6.4 gigabytes of data, which we previously mentioned. So that's 6.4 gigabytes of data loaded across a continent in less than 2 minutes, which is pretty good. What I'd like to do is I'd like to make that even faster. So what I'm doing now is I've truncated that table. I've gotten rid of the data again, cleared it out, and I'm using our large warehouse. So just like that, with just a single click, I've swapped from using a small warehouse to a large warehouse, which is 4 times as powerful. Since it's 4 times as powerful, I would say we're probably going to shave off about a minute from that loading time, getting that ultimate load of 6.4 gigabytes of data down to less than a minute. I would estimate probably between 40 and 50 seconds at a guess. And it's worth noting as well that I've chosen a large warehouse, but as you saw, the sizes on warehouses go up from large, extra large, double extra large, up to 4 times extra large, and they exponentially improve in performance each time. And this is still only a single warehouse. And again, we can see the same results now at the bottom of the screen. So that's pretty nice that we can load data in that quickly. But what about query times? What I'm going to do is I'm going to show querying this data first in Snowflake and then also playing around with it in Tableau Desktop, because that really is where we can just play around with this data and move it around and just fiddle without needing to worry about writing code. So first, I'm going to run a simple select count. So I'm just going to get simply the number of records within my data set. I'm querying again this table of 148 million records joined to 4 other tables. And you see in 1.76 seconds, I've returned my count. Going a little bit further, let's look at the carriers and the years. So number of flights per carrier and per year. And we can see here we do, top of the list is Southwest Airlines in 2016, which apparently had 758,000 flights. Now I can tell you actually we only have half data for 2016. So I'm going to scroll down to 2015. And we can see there Southwest Airlines had 1.26 million flights. And this is a table of 354 rows, still spanning our 148 million records, and queried in 1.5 seconds. One more I'm going to show. This is now going to be every origin and destination. So the number of flights per origin and destination in the US in total. So here we have 9,316 possible combinations of origin and destination. The top one has 351,000 flights. But again, 2 seconds query time to query this pretty big data set with a relatively medium-ish size, or actually a low-sized warehouse compared to what's possible. So how about in Tableau? What I'm doing is I'm just quickly creating a view which we're going to use in Tableau, which has already joined those tables together. But as you can see from this count, we are still dealing with 148 million records. So this screen is Tableau Desktop. This is Tableau's main authoring tool, which I mentioned earlier, where we can connect to data and then build dashboards and use drag and drop to build our own analytics. I'm going to connect using more. I could use Snowflake on the left, but just to demonstrate for anyone that hasn't used it already, I can click on more, type in Snowflake and find Snowflake already here. It's a native connection in Tableau. It's already designed and built in. So Tableau and Snowflake, well, Tableau is built with the support to access Snowflake. So I log into our server. Again, I select my warehouse. So I'm going to go for our large warehouse again. I can select my database, which is my brand new database that I dropped 10 minutes ago. And I'm going to connect to my flights view. So the way Tableau works, we're using what's called a live connection. So what Tableau does is it looks at what I'm asking for, converts that into a SQL code, sends that SQL code out to Snowflake. Snowflake will then read that SQL, process it, run the query, return the data out back to Tableau. And this is now Tableau just sitting on my local machine. So I hit update, that query goes away, that goes off to Snowflake, and you can see a couple of seconds, and I've got this data. This is still 148 million records being queried, all 50 columns, plus the ones we're joining to in the other tables, in a couple of seconds. So let's have a little bit of a play. So if I go into a new sheet, the advantage of Tableau is that it's entirely drag and drop, and it's really flexible, it's really helpful. So I can just say, okay, what I'm interested in is I'm going to be interested in flights over time. I can put in my flight date, and Tableau automatically populate my years. And then I can pull in my number of records or number of flights. So here we see a yearly view of the number of internal flights within the US. As I mentioned earlier, we only have half a data set for 2016, so that's why we have this dip at the end of 2016. We can also see a dip in 2002, and anyone familiar with US history can understand why that is. So this is a yearly view. This is a line chart of 25 years, still showing 148 million flights, returning a matter of seconds. But we can do better than that. So I'm going to change this to the exact date. So instead of being 25 years or 25 points of data, I now have roughly 9,000 days. So each of the vertical lines here is a day. And this really highlights the seasonality of flights as well. You can see all the bumps and dips as we enter particular seasons where people are more fond of traveling. And the really interesting one, at least for me, is this single day that drops every year, which is actually the American Thanksgiving. Just turns out that it's much more rare for an American to fly on Thanksgiving, which I think is quite interesting. So as I say, that's 9,000 marks, but again, I want to do better. So I'm going to break this down by the airline as well. This creates a pretty interesting looking view. It looks a little bit like a piece of artwork, I think, at first, as you see almost like someone's just kind of flicked a paintbrush at the wall. But it's pretty interesting. I'm going to change this to circles as well. So what we have here is every circle on this chart is an individual point of data. It's a day and an airline and the number of flights that occurred. This is 126,000 marks of data being pulled through, still spanning 148 million records of data, and it returned in a second, 2 seconds. It's really quick and easy. It's really quick to build something like this in Tableau. It's really easy, but also with Snowflake behind it, it's just really fast, which is just, in my opinion, a really helpful tool. Something else we can do in Tableau, if I just nip across to an earlier workbook which one of my colleagues created. So this is a workbook built on the same data set. In fact, it's actually pointing at that same data source, at that same database that we're currently using. So when I dropped that database, if I'd used this workbook before creating it again, then this workbook will be telling me that the database isn't there. So again, no caching, no warm up. And what we have is a pretty nice looking dashboard, just running through number of flights and how they compared in regards to which were on time, which were late or very late or cancelled. And down here we have the top 10 airlines. And because of the way Tableau works and the user experience behind Tableau, I can click on an airline and filter the rest of my dashboard to show me the data just for that airline. So Southwest Airlines, between 1993 and 2016, had about 23 million flights. American Airlines, 15.6 million flights. Delta Airlines, 17.5 million flights. So I can really quickly click between each of these airlines. And what you don't realize really is going on here. Every time I click on one of these, this data is having to be retrieved from somewhere. So the combined power behind Snowflake and Tableau means I'm filtering this dashboard on the fly almost instantly with each click. And this is still filtering our full 148 million record 6.5 gigabyte of data, which is pretty impressive. This concludes the hands-on demo portion of the webinar. I'd like to talk you through a few more really great features within Snowflake. The first of these features is time travel. As a result of how Snowflake's architecture stores data, it is easy to retrieve earlier versions of tables, schemas, and databases. And this can be helpful for a number of reasons. One example could be if an undesired change has been made to a table. Instead of rolling back the table, the database, or even the system, as may be required in a traditional data warehouse, in Snowflake, a single piece of code can be used to retrieve the data as it existed at any timestamp in the configured history. This extends the data which has been dropped or deleted. Using the undrop command, data can be easily restored if unintentionally deleted. Another great feature within Snowflake is the ability to easily and instantly clone databases, schemas, and tables at no charge. It is very common for businesses to run equivalent environments of a system, one for production, one for development, potentially another one for quality assurance, etc. In Snowflake, you can create unlimited clones and will only be charged based on the difference between each clone and its origin. This can be combined with time travel. For example, we may want to create a clone using the data from last week and then compare this week to last week. Finally, let's discuss data sharing. Traditional data warehouses face many limitations when it comes to data sharing. A typical method of sharing data is to transfer it via a secure file transfer protocol, or SFTP. Another method, which is a little bit more hands-on, is to export the data onto a hard drive or even a USB stick and physically transport it to the customer or to the consumer. These methods are clunky and often require the consumer to put time and effort into preparing and loading the data into their own system before they can use it. Snowflake data sharing was designed to remove these barriers and unlock the ability to move real-time data at unlimited scale between organizations. You don't create a copy of a dataset and move it across organizational boundaries. Because of Snowflake's unique architecture, a data provider is able to define a customized slice of their data and simply share a reference to that data with another Snowflake account. This means sharing is completely free. Your only cost is the storage which you're already paying for the data. Consumers can then use their own compute to query that data. So this concludes the agenda for today. We've covered a lot of content in a short time, and I'm hoping I've given everybody something to think about. I'm going to display a few links which you can use to get started with Snowflake and Tableau, and pass over to Vicky.
Wonderful. Thank you so much, Chris. Right, we have left quite a bit of time for questions and answers. So if you do have a question, could I ask you to either raise your hand, and you'll find that within the participant section, or if you would like to send a quick chat message, we'd be happy to answer any questions that you may have. I'm going to leave this open for the next 10 minutes or so, so please feel free to ask any questions and we'll be happy to answer them. Okay, if there are no questions at this time, it's worth me letting you know that I will be sending out the recording along with the links that you're currently seeing in front of you post-call. If you do have any questions or queries or something pops to mind later on, one of our account executives will drop you their contact details so that you will have visibility or the opportunity to answer any questions. But without any further ado, I'd like to say thank you very much to everybody who was able to attend, and we hope to see you on more of our webinars or at some of our events. Thank you very much for joining. I'm going to end the call there.